It's recording, right?
Yeah.
Okay. Yeah, we can start. So let's start with the first problem. They're giving in an alien language. Surprisingly, they also use English lowercase letters, but possibly in a different order. The order of the alphabet is some permutation of lowercase letters. Given a sequence of words written in the alien language, an order of the alphabet return true if and only if the given words are sorted lexicographically in this alien language. So if we look at this example, so it's not a normal order, but it will consist of all the alphabets of English, and they have their own order order of arrangement. So here you can see the first letter of this word and the first letter of this word. Since H comes before L, so you can see that here the order is H is coming before L, so it's a sorted one. So you'll return true in this case. Going to the next one, uh, you can see here this W is common over here, but if you see again, if you see ORD, if you take the sorted, it's in a proper manner, but the last word, this D, is coming after L in this language. Here you can see this D is coming after L, because of which this this is greater than this, hence you can say this is not sorted, this particular word, so we are returning false over here. And again you can see the here the first three character of this matches with this second word, but the second character is shorter in size. So since now you'll have this once you finish app, you'll have lne, and here you'll have null phi. So which will be a which is considered as a blank character, which is less than any other character, hence we are returning false over here. So any queries in the examples, or blank will have the least precedence.
So basically, here we are applying the lexicographical rules. Only thing is they have given a different order. We generally go by A, B, C, D, where we say
Yeah,
A is smaller than B. But here, if we see
they have their own orders.
their own order, like in the first example, H is smaller than L,
Yeah,
and H is also smaller than A. So basically, if we get their order and then have our own comparison, like how the compiler or the language does the lexicographical analysis. I think that's what we need to do here.
yeah.
So if I take all if I store if I give them precedence, like H is, let's say, 0, L is 1, A is 2, B is 3 in the first example,
Encode.
and then it will go till 26. Then we'll take H in the first, like it is hello and lead code. So H is lesser than L, we are good. L, E and E, they are same. L is smaller than E, that is also good. Then another L is smaller than T, that is also good. O should be.
Since first character itself is what is
So
matches.
lexicographical rule says, like, if one of them is smaller, then we don't check the rest of them. So if we find
Yeah,
H is
exactly.
smaller than L, that's where we are good. Yeah.
Yeah.
So basically, the lexicographical rule says if I have AB, like in normal, without considering this, if I have AB and I have only B, so AB would be smaller than B, right?
Yeah.
Because we only check for the first character, right?
Correct. Yeah. Because after that, empty will be there. No, B doesn't have. You're comparing A, B, and B, right?
Yeah. So if, let's say, if there is no rules and we are going with A, B, C, D, if AB is there and B is there, which one is smaller?
A should be smaller, right?
Huh?
No, so I have two strings, A, B, and B.
Two separate
A,
strings.
B, and B, then I think, oh yeah. So A, B will be smaller because A is lower than B, right?
Mm-hmm. So after that, we don't check rest of the thing, right?
Right, right, right.
So I think this
Because
is,
B will have empty space, so that empty character is less than the B or less than the character of first one. So I think AB will be. Um,
so I think if we define the lexicographical rule, then the order, then we have to just introduce the order. So I think this is a good example to think about how compiler resolve the lexicographical thing, because there are a lot of questions out where they tell you, okay, which one is lexicographical or smaller. And I, so, do you have a you have a Python on your local,
Jupyter notebook, yeah, I have. I can.
or you would have a command prompt. You can just run
Yeah, I
command.
can. Yeah, sure, sure. I'm trying. Mm,
And just write Python. If you write Python, if you have Python, we can even do it here.
Notebook also within screen is visible, right?
Yeah.
Yeah.
Okay. So if you write quotes AB,
Within quotes.
mhm,
Uh,
greater than B. So let's say what comes.
It's
what?
less than.
Mm,
Yeah, it's less than. It just compared
yeah.
the first character, and if it is smaller, then it won't go to the next character. That's how the lexicographic work.
But that should be true, right? If A is smaller than B.
No, but here we're checking for AB greater than B,
Greater,
right?
yeah. Should do it for the lesser one, yeah.
Mm,
Because AB is smaller than B, right?
Mm-hmm.
So then what it's outputting is right, yeah.
no, it's false. A is smaller than B. That's false. That's correct, right?
Yeah,
The
that's
first
correct.
character.
Yeah,
Yeah, yeah, yeah.
it goes with character wise. Like first character, if it is not matching, then it doesn't even look into the rest of the characters. It just says
Character.
it's less than. That's it. No matter how many, what is the length of the character.
Let's say if I have A, B, C, D, and A, B, C, then what should be in this case?
So it falls.
False.
So
No,
I think
true. True. I think this is true.
Because prefix, the entire ABC lies as a
Oh yeah,
prefix
yeah.
in
This is
the,
right, yeah.
yeah.
Because the length of ABC is smaller, no?
Yeah.
Because after C there will be a space, right? I mean,
There
it
is
gets
no character after that, so yeah.
I
no,
mean, D is greater than null, kind of.
yeah, because of that.
so. I think the other way to write is to understand properly is the first example only AB.
Hmm.
Uh,
Yeah.
AB less than B. Yeah, so that's what we are trying to prove. So it should be,
It should be true. Yeah.
that's
Hmm.
what the other way to see this thing. You visualize that AB is smaller than B. Although AB has more characters, but we only go with character by character.
So first priority is to check the first character of both the words.
Yeah, if
If it,
smaller, that means that the string itself is smaller. We don't go for the.
and next would be if the length of first, like ABCD, if the length of this word is greater than this. I mean, once the first character matches second.
So if everything is same
Hmm.
and the other string has a greater length, that means we will win.
That means if this string is a prefix of this bigger string, then in that case it will return. This is a prefix only, no? ABC is a prefix of ABCD.
MC is same, and now the length will decide the whose length is bigger will decide who will win.
Yeah,
If
who will win, huh? Hmm.
And so yeah, so this was, I think, generally just the ABCD rules. Now the question, same thing, but he told to use his rule of ordering which character is bigger and which character is smaller.
Yeah.
I think rest all the rules will be same, a flexographical thing.
In the first example, after like they check for H and L, why do they don't check for the rest of the characters? We also need to.
So that's what we are discussing, like how the lexicographical thing works. So basically, how compiler evaluate. Shashank, can you again open the Jupyter?
Sure.
So that's why I told to bring that up, because that is confusing. So if you see how even any compiler works is, if you see the last example, AB lesser than B. So we don't see the resting. If one is smaller, if A is smaller than B, we don't go and check rest of the characters. That's the property of any language or the compiler.
Okay.
So that is actually lexicographical rules. In the same rules will apply in the question.
Yeah.
Only difference is there we know A is smaller than B, but there he told there is an alien language where they don't follow ABCD, they follow HIJK. That is how they start with their characters.
Okay.
Rest of the rules we have to be, we would be applying in the same way how compiler applies. That's the trick.
Yeah. Okay.
But they haven't mentioned such rules like here, like, I mean, that we know because we had knowledge of compiler, how lexicographic parser works, right? They haven't explicitly mentioned anywhere like.
They didn't mention that. So I tried the same thing on my own, and then I found, okay, that's what he might be looking for. Otherwise, he didn't mention all the rules.
Yeah, exactly.
He just mentioned somewhere down, he told lexicographically, that's it. I think that's now up to us to find out what lexicographically actually means.
Okay.
Because this is confusing for me also, like why only check first character? Then I went and read all the rules, like how it works.
So the first rule would be that match with the first character, right? If it matches, then we don't need to go further.
So if the first character is smaller than the first character of the other one, we are good. If they both are same, then we'll keep on going further. And if we find the greater character also, then also we can just return false immediately. But there is one more rule, like you mentioned, ABCD and ABC. Then the length
prefix one.
Yeah, then the length will also play. So basically, 3 rules, kind of.
Yeah.
So one was like this: AB is lesser than B. So that was true. Then the other rule was, let's say, B is lesser than. If you go to line up, you can put B is lesser than A. So that is the other rule where, so this will be false.
Yeah.
And then
if we
so these are the kind of 3 rules from line C, line 3, 4, 5.
What about this?
This is very similar to dictionary sort, right? I mean, in the sense how it is in the dictionary. That is, lexicographic is nothing but as per the dictionary. That's what I thought.
Yes.
So
no, dictionary. Okay.
Yeah, like the English dictionary, So in that, ABC will come before ABCD, but B's will always come after A's. Like however big the word is, A, the B will come only after A.
Yeah, that's a technology.
If you take an example of ABC and AAA.
Greater than or what you're saying? Less than?
Less than?
AA, triple A.
Triple.
So
in the
false.
dictionary, AAA
It's
will come
false.
before ABC if you are looking at the dictionary wise, doing. That
Yeah.
is what is lexicographic.
Yeah, that's true. But in the logic, they're not going to check the other words, other characters after checking the first one.
no,
Like in
no,
the
they will check. If A and A is same, then we have to go to the second character.
B and A, yeah.
Then B is greater than A, that means it is false.
So only check for the characters which are different.
Yes, you start from
Exactly.
left to
So the
right.
question is little confusing actually. So they are like checking character by character. If there is any mismatch, then they are checking the positions of that character in the given order. If the first one is greater than the second one, then it's good. Otherwise, they are returning false.
No, basically they are looking for lexicographically rules. That's
Yeah.
why in this Jupyter notebook, if you see, we are using Python as a compiler. We haven't even applied any question logic here. We are just going simply what if ABC is my language, what would be my answer?
If ABC,
So instead of his alien language, if ABCD is like regular, what is ABCD, what we use is if we are using to create words, what would be the answer I will get if I do ABC lesser than AAA?
so A and A is matching, so we'll go for B and A. So what? This one you are
Yes,
talking about?
yes,
It will be
line
false.
7. Yeah,
Yeah.
so this is false because B is greater than A.
A and A is matching, so we'll proceed for next character. B will match. B will compare with A. B is greater
Which is
than A. So yeah, false.
it is
Yeah.
false.
Mm.
And if you put ABC uh, in the next line,
Okay. Mm.
ABC lesser than ABCD,
This should be true.
which should be true.
So
Yeah.
And then now we have to do the same thing in the question.
So yeah, I'll show you what I've done.
Mhm.
So first I encoded the words. I mean, gave them the numbers corresponding to each character according to the order they have. Like H will go 0, 1 will go, L will go 1. Yeah. After I'm taking pair of each words in the dictionary.
Mhm.
Like let's say here only 2 words are there. If more than 2 words are there, we'll take pair of words, and I'm comparing that length one and checking if the second word, this word, is a prefix of this. I mean, like this one, ABCD is there, like this. One is ABCD and other is ABC. Now, this ABC is a prefix of this bigger word, right?
Mhm.
So in that, and then all the characters of the second string will get exhausted when it reaches D. So in that case, will return. I'm taking those cases where it can be false because that, yeah. And after that's one case. After that, I'm going through each character of the words, the 2 words. I'm checking if the first character of this, of the value of this is greater than this, then again, it is not acceptable. Else if the first character is in proper order, we'll come out of the loop and return true for it. Yeah.
What
Or
if
any
they
other approach?
equal?
Say
What if they equal?
Then I think
equal. I
that
think here you are saying E.
So if they are equal, it's going to go in the for loop, the last second for loop.
Well,
Because
yeah, but
if and else if
then
they are
I mean,
not
some of
matching.
them are the same, but like one of them are equal.
Yeah, so it will run in the for loop. It won't go in any
it will
other
go
case.
till
Right?
end of the for loop and come out.
Yeah.
Oh, okay. But I feel like checking online numbers, checking the prefix is like we don't need to do that, right? Because anyway, if we go into the for loop, they're gonna do it. Because when we go to the for loop, we're gonna choose 2 pointer anyway. So if the prefix, it's gonna be the prefix.
So basically, if he don't do it line 7, then after coming out of for loop, he has to check wherever he reached till C1 or C2. because they could be different lengths. C1, W1 and W2 could be of different length. So at the end, he has to do some kind of so there could be like W1 is smaller than, or W1 is greater than W2. So then he has to just check if after coming out of for loop, if W1 was greater than W2, just return false.
So either you do it at the top or you do it at the end. Somewhere you have to do it, yeah.
Yeah.
In the zip function, does it take the length of the smaller one?
No, it will take pair of words like two word. I mean, it will take one word from list. If 3 words are there, it will take pairwise. Like word, world, it will pick. Then world, row will pick like this. Zip function.
But what if they're not the same length?
No, it doesn't take length. No, irrespective of length, it will take whatever the length is. Like you are saying that if both the words are similar in length,
it's not the same length. Oh, because you already checked on the. Yeah, okay.
Oh, this one.
No, I already checked.
No.
Okay.
Okay.
We're good.
Yeah. So does Asim also has its code to share?
Oh yeah. Share my code.
Okay. Let me stop.
Okay, please let me know when you can see my screen.
Yeah, we can see.
Okay, so how I did was like how I was explaining in the same way I was doing, taking all the characters from the dictionary what we have given and put them in a map. Then start taking each word 1 and word 2, take their minimum length out of that, and if the character if they both have the same character, I can continue. Otherwise, that means they are both same. Otherwise, I will take their from the map. I will take their value, and if number 1 is greater than 2, else it is false. Otherwise, I'll break. At the end, I'm just checking their length. So I went with the smaller length, if you have seen here, and at the end I'm just seeing like if my J reached till length, that means all the characters are same. So that means if at that time I will just say if word 1 is greater than word 2, then return false. That's it.
Yeah, that's clear. So yeah. So where was this num1 greater than num2 in Shashank's code? I don't remember seeing it.
Shashank also.
I think you have to stop sharing them.
It's like 21 when we compare the mean, we get the mean of the.
After for loop, I was doing like length of W1.
Oh, it was just the length, but not the integer that you assigned in the enumerate, like for the hashing.
No, I was that enumerate function I've taken no for encoding. I mean, corresponding to each character, I'll be giving the values.
Oh yeah.
Okay.
No, we can proceed to next.
The other way to do that, I think, is to override the comparator. Whatever, if we have a comparator function, and then we can override the comparator, and I think it's the same, but the code will be a little shorter. Because at the end, we only compare if this string is less than the next string, right? And we have the comparator, if we return it, it's -1, 0, or 1.
Actually, that's true. If you use comparator, we don't need any data structure. Like we don't need any map or something. We can just compare.
Can you share? You have code for that?
Yeah.
Yeah, sure. Share it.
I had to rejoin to share my
No,
screen.
simply you can share it. Share screen would be there on Zoom option.
Yeah, but I never shared
Mac.
this. Okay. Yeah. Okay, I can share.
Yeah.
Okay, you can see my screen, right?
Yeah.
Okay. So here is the code. Like I'm just looping through the words. I wrote a compare. I'll explain about the compare function. So or the comparator. So I'll take first word and the next word, like 2 consecutive words, and pass the order along with that. So here I loop through every characters, taking the minimum length of first word and second word length. Like in case of Apple, APP, LE, and APP, we need to check up till only APP, the minimum length of the word. So I'll check through I loop through the minimum length, and if I check if first, A dot caret of I not equal to B dot caret of I, like character by character, I'm comparing which one is not matching. If it is not matching, then I am returning the index of, like, in which position the character is present, like the unmatched character is present in the given order. Index of A dot caret minus order of index of, if this is like greater than 0, that means they are not in a lexicographic order. If it is less than 0, A should always be greater than B. So if it is that way, then it is not in a lexicographic order. So if we are not finding any match character, then we are simply returning the length of this, like length of the 2 strings. Again, if length of first word is greater than length of second word, then again return false. Yeah, return false.
Yeah.
So here you are actually avoiding using any sort of mapping.
Yeah.
Instead of
Any data structure. Yeah, I'm simply using
and he's optimizing also by using that min, comparing up to the minimum of those 2 words.
Yeah.
Small
But
optimization.
we are doing order dot index of, that would be costly. So
sorry.
So at line 13, there is order.
Oh yeah, it is going through each and every alphabet.
So every character we are going and trying to find, that would be like order of n, find operation.
At least a order of 26, yeah.
Right.
That's a constant only.
Yeah, that's a constant.
Is it? It's not.
No, if you use a map, it will be constant, right?
Yeah, but it's a string. It's not constant.
Yeah.
Length of token.
Yeah, that's it.
Okay.
I can stop sharing. Yeah.
Yeah, sure. Okay.
So what can we say at the time complexity for this? So I think the length of the word, or like what?
Length of the array into the length of the word. For first case, you can say length of the array is n,
Order of
and
nk.
into k is the max of the word, max of lengths of all.
Yeah, yeah. I think it should. Order.
Which bench becomes the total.
Pardon, your voice is breaking, it seems.
So I think definition of content is like total number of words into
Yeah.
the average length of what you by the
So it's taking all the alphabets, each and every
yeah
from the whole
yes.
string. Yeah.
Okay. Okay, let's switch to next. Or any queries in this one?
So you can go and
Okay. No. So the minimum add to make parenthesis valid. For string of open and closed parentheses are given, we need to add the minimum number of parentheses, this open or close, and in any position, so that the resulting parenthesis string is valid. Now the validity of a parenthesis string is defined. If it is empty, it will be valid. Can be written as A concatenated with B, or where A and B are valid strings, or it can be written as simply A, where A is a valid string. So given a parenthesis string, we need to return the number of parentheses we must add to make the resulting string valid. So these two will counterbalance each other. So for this we need 1. So output is 1, and corresponding to this 3. And here already it's balanced. And for this they'll balance each other. 2 for this one and 2 for this 4. And string length will be less than 1000 and consist of only open and close braces. No, any approach in this or queries?
think we can solve it using stack.
I mean, yeah.
Yeah, so if we encounter a closing braces,
Yeah.
so we'll put that into the stack, and if we encounter a opening brace, so we'll remove, if we will check into the stack, if the element is present, we'll pop, and if the element is not present, then we'll add 1 to the result. And
Yeah. At last, take the
at
whatever is
last,
left.
yeah, whatever is left. So we haven't found those opening braces. So whatever
Yeah.
is the length of stack, that also we have to, I think.
Take, yeah. Yeah, makes sense.
I just did that without using stack, kind of with counter that counts positive and negative for opening and closing phrases. Like
Left and right, you might.
yeah, so instead of using stack, we can use a counter, and based on that, we can do it, right?
Yeah. You want to share?
But
I
I
think somebody
think
has
the
to
you can
switch off
share.
microphone. Sound is. Yeah, you can share. You want?
Yeah. Okay.
Yeah, sure.
Can you see my screen?
Yeah.
So like instead of stack, I just took a count parenthesis variable, and I just went into each character of the string. The count parent is 0, and we encounter a closing phrase that's like stack is empty, and we got a closing parenthesis. So I just added that into the result. Otherwise, if the closing parenthesis is not 0, and we have a like closing parenthesis, then that then that means like we don't need to add that. So the closing parenthesis decrease that, and this else is like we get to opening parenthesis, we just increment that, and at the end I just like these are the all the remaining opening parentheses that doesn't have a closing parenthesis, so I just added that and returned that.
Yeah, makes sense.
So you are actually adding one whenever you see an open parenthesis to the count parenthesis, right?
Yeah.
And then you are subtracting one if you see a close, a corresponding or
Yeah,
not.
right.
Yeah.
Does it pass
They're
all the
balanced.
test cases?
Yeah, it passed.
And if
Both
you,
the characters are same. I mean, they are both closing bracket.
But
yeah,
Yeah.
the
how
else
do
part
we
text.
check it for the validity?
Like see, I'll give an example. Like if this is a balanced one, this the result has to be 0, right? So like I go into the string, and first I encounter the opening parenthesis, so that goes into else part, which increments the counter by
Now, see, so you just don't take this example, just the last two brackets, move it to the starting. Then you.
okay.
No,
Like this, right?
of course, that was a valid one.
Yeah, is this okay? Like this one?
Yeah.
So now we got a closing parenthesis that goes into this if condition, first part, as the counter parenthesis is initially 0, and we got a closing parenthesis. So I increment the rest counter by 1, and again I got a closing parenthesis, then the rest count rest equals to 2. Then I encountered the opening parenthesis, so it will check for this is not a valid condition, this is not a valid condition, as
The last
it's
one, right?
so this
Last
goes
one, yeah.
yeah, so
Your count is increased now.
count equals to 1.
Mm.
Then again it's an opening parenthesis, so that again it goes into the else condition, count equals to 2. Then we reach the end of the string, then it will return res plus count parenthesis, which is 2 plus 2, 4.
Yeah. So your first count parenthesis, whenever it looks for a 0 value, right, it means they are balanced, right? And if you still find something, a close parenthesis, at that time you increment the count. That is the most important thing there, right?
Yeah, that's
okay.
So I think we can use a similar approach to check the validity also. I think we normally use stack to solve that problem.
But he's not taking any extra space.
Yeah. So that is what I'm thinking. Can be used to check whether the parenthesis is valid or not.
No, but in validity you have different types of braces, right? Here you have only.
Okay. Then here you have only 2 types. So okay, one type.
Mm-hmm.
That is the catch.
That will be complex, I think, in that.
Yeah. Thanks. I think it was a solution.
What is that he was actually talking about?
Yeah.
He's telling
So
this approach to check the whether the parenthesis, like you have opening 2 opening braces, close and curly braces, box bracket. Yeah, you have to check whether they are balanced or not.
Oh,
So
all of them. All the 3 types. Yeah. Wow. Okay. Yeah, that is very complex.
Actually, you can maintain 3 variables if you know that there are only 3 types. And use this approach.
Yeah, that
maybe
can be. Yeah.
Can be, but it will be. But
yeah, it will
we are
be
not
like
using any.
won't be a statements, verbose and prone.
I think 3 different types of variables, and corresponding to that.
Yeah. So a lot of code be
Yeah.
added.
But might be possible. Yeah.
Yeah, if somebody can try, it will be. I think it will be.
If there are any doubts, then should I stop sharing?
I think it will be order of n only, right? Entire length of a string, what you are going.
Yeah. So I'm iterating this only for loop that iterates the whole string and return the value.
Yeah.
Automation.
Yeah, you can.
Okay.
Yeah,
Stop getting.
yeah, sure.
If for the previous, if it wasn't clear with the naming, can we go back to the just real quick?
Yeah, I think sure.
Yeah.
Dilip has to share the screen.
Yeah, I mean, if somebody's still confused about the naming of the variables, the rest would be kind of like extra opening.
Yeah, I mean like
Extra opening, and then count parentheses is going to be extra closing.
Yeah, that will be more.
Can we
Count
rename them and see
no,
if it makes sense?
but the count parenthesis will be both, like a balancing of the both. It's not only opening, right? It is both. Because he is adding one and decrementing one. So he's trying to maintain a balance there. So if you have a
Rest.
balanced, so that it becomes 0.
And rest will be also for both. It can't...
No, rest will only be for correct. Rest is correct actually.
Let's rename them and see if it makes sense. Let's do rest to be extra opening.
Extra closing, right?
Extra opening, and count parentheses extra closing.
I think rest will be extra closing. Okay.
No.
Yeah, whatever it is. Yeah. Okay.
Yeah. Let's see. So count parentheses.
Yeah, like is this extra closing or extra opening?
Extra opening. The rest.
Okay. Okay.
So let's see. If not extra closing, maybe the other way around. Extra opening. Extra opening. Yeah, I think I have it the other way around. Okay. I'm sorry, man.
No, it's okay.
Okay.
Yeah, got it. But yeah.
Yeah, I mean, just to make it more descriptive, so we can understand. I mean, I don't know.
Right. Yeah. Or else the variable names are a bit confusing sometimes. You don't understand it properly. Yeah, that makes sense.
Yeah. Okay. Cool. Thanks.
Thank you. Yeah.
Thanks.
It's a very clean solution, no stacks and all. Cool.
Yeah. What I used is like I created a deck like for corresponding to opening you'll have closing. So for every character, wait, what is happening?
But stack is very intuitive and very easy to come up.
Yeah. That was my first intuition, like first thing to do.
So
but I think it's faster. I'm sorry.
But at the cost of space, I'm doing. But he's not using any space now.
Yeah. That too.
So for every character, if it is this, I mean, we have only one character like this one, so we'll append it, and we need to check if the stack is not empty, or the other case is like if whatever you're popping out from the stack, if it is equal to this, then then in that case you need to increase this count, and at last just check the length of a stack to this count, add it, and return the count.
Cool.
Yeah, let's proceed to next. Or any queries on this?
Nope. I think let's move on.
Okay. Yeah, this one. Minimum increment. We need in order to make the array unique. We are given an array of integers, and a move consists of choosing any AI, increment it by 1. So we need to return the least number of moves in order to make every element here unique. Let's say this 1 to 2 is given. So If we make 2 as 3, all the 3 numbers would be unique. And here, after up till 5 moves, it was not unique. So after the 6th move, the array was like this. I mean, it was unique. This is the length, and this was the length of array is up to 4k. Sorry, 40k, I think. And yeah, it's the number lies from all of them. All of the numbers will be positive here, and it will be less than 40k. Any approach in this or any?
Think can use sorting.
Sorting, yeah. After sorting, how would you proceed?
So then I'll start iterating and I'll check if like first number would be the least, second from the second number I'll start whether it is equal to the previous one or not. If it is equal, then I need to add one to it and also maintain what value it will take. And then I'll the next one and check what was the value that previous one had if it was changed. If both of them are equal, but then I'll add one bit.
Oh yeah, you are saying like you'll sort this first, right?
Yeah.
I think. So let's say this is a string. So after sorting, you'll get this. Now we are checking whether the element at 1th index is lesser than this. If this element is lesser than this, then we need to take the difference, add 1 to the difference. And the reason behind adding 1 to the difference is because here the two numbers are same. If you take the difference, it will be 0, and if you update it same, it will remain 1 again. So we are adding 1 to it because and secondly, they have told minimum increment. I have to increment it by 1. And move consists of choosing and least the number of move least return the least number of moves to make every element in. Okay, so this we are doing if the number is similar, then to make a difference from this number. So
Yeah,
after adding this, it will be 1 2. Now again you can see these two numbers are equal, so take the difference is 0, a plus 1 we are adding, so 3 plus 1. So difference is 1, and this difference we are adding to the this number. Similarly, you can check for this. These two are again similar. You can add the difference. But the moment you find that this next element is greater than this, then we don't need to do anything as it is, I think. Or any other approach if someone, or any queries in this approach?
I think this modifies the array.
Yeah, it modifies the
I took a like an array a list of size of 10 to power 4, like 4 into 10 to power 4. That's the size of the input size. So I just incremented with a 0 initial values, and then I move on that with a 2 pointer, 1 pointer for index where the value is greater than 1, and other one at the 0 next to 0 value. Then I increment and
I
move
think
on
you
like
share the screen, it will be better. I mean, you can like by writing it will be better. Yeah.
Okay, sorry for bad namings. Actually, I'm really bad with that.
Okay.
So I just took a underscore counts, like array counts of size 8001. That's because if all the elements inside this array or 4 into 10 to the power 4 repeated that many times, then we need to increment that to until 8 into 10 to the power 4. That's why I took the array size of 10 to 8 into 10 to the power 4, and I given value 0 for like initialize with 0. Then like I iterated to array and incremented at that index. So this looks like if for the initial input, like 1 to 2, we have 0, 1, 2, 0, 0 on go on like that. So I just maintain the counts of all the elements in array A. Then what I do is first this num pointer will be at position of first the index where the elements are more than one in one location. Like here the 2 repeats twice. So my num pointer initially will be at index 2. And then I take a 0 pointer that will be starting from num pointer here and move until the value at index is 0. So my num pointer will be here and the 0 pointer will be next to that. So I have 2 here. So after I go into this loop and I decrement this one to 1 and increment this to 1 and add the value between difference of that to my result. And I move on like that to all the numbers until I reach my num pointer to 4 into 10 to the power 4 and I return the count. Should I explain the coding chat value? So in for loop actually, so if num pointer value is greater than 1, then I do that. So I increment a counter of 0 pointer minus num pointer, which is a difference of the next available 0. Then I increment the 0 pointer and num pointer. And then I move my 0 pointer to next available 0 with this while loop. If it is equal to 1 or 0, then I move my num pointer to the next index where the value is greater than 1. Then I move my 0 pointer to next available 0 and the loop goes on like that. Should I explain with an example or like?
No, you can go with example. That will.
Yeah.
Second one take.
Okay. So first I construct my this A counts like array counts. Which are having all 0. Then this goes on until 4 into 10 to the 4. Then I iterate through this array. First I got 3, then I go to index 3 and increment this by 1, then index 2, 1, then index 1, 1, index 2, then value 2, sorry. So it incremented by 1, then again 1, then 7 by 1. So this is how my array counts looks after.
One index 1 has to be 2, right? Yeah.
Oh, sorry. Yeah. So this is how it looks after this loop. Then I have 2 pointers. One pointer is num pointer. So that I move on to this A count and find first index where the value will be greater than 1. That's 1. So index pointer will be 1. And I take my 0 pointer, which is equal to 1. And I move on the same array counts until I find a 0. So it starts here. So 0 here is also equal to 1, and then I move on until the value is not equal to. So like I move on until here. That's index is 4. So my 0 pointer value is 4. Then I go into a loop until this num pointer is less than 4 into 10 to 4, like 10 to the 4. And so first at my num pointer, the value is greater than 1. So so value is greater than 1, and I need to increment that to 4 to make ones as to make ones as unique. So for that I get a cost of 4 minus 1. So I add that into my result. 4 minus 1, that's 3. The cost of this I get is 3. Then now this becomes 1. I decrement that here. So then I move on my num pointer to next which have greater than 1. So first I move my 0 pointer to next non-zero value, which is next value. So my 0 pointer will goes to index 5. Then I go into loop and see now my value of this my num pointer is 1, which value is 1. So this one. So I go into else condition. Then I move on until my pointer until my value at that index is greater than 1. So it will increment by 1 and exit here. So which is at index 2. Then again my 0 pointer is 5. Now I need to increment my value to 5. This one is 1. So I need to increment 2 to 5. So that will cost me 5 minus 2, which is 3. I do that and I decrement this and I increment this. Then I move on like that until 4 into 10 to the power 4 until I find all whether any value greater than 1, and I do the same process. So at the end everything will be either 1s or 0s, and at the end I will get the result. Yeah, so answer is 6. Like that's how I get the value. So these loops, this is a whole loop that iterate on that until I reach 4 into 10 to the power 4. That at that point, that means I iterated to all the values possible and made it as 1. So and I calculated result. Is that clear? Any doubts?
Yeah, it's only the array size. You have to take a big array, right? That's only
Which is integer max
yeah.
value, right?
No, actually, he takes whatever the length is specified here in the note section.
Oh.
So he's just taking twice of it, yeah.
Yeah. So
okay.
Generally, we can maintain only 10 to the power 4 size, right? Like max, we can maintain a size of 10 to the power 4 size.
Yeah, because
depends
if you're
on language.
Yeah.
But in coding platform, they provide a space of. I read somewhere.
10 to the power 9, I think you can go.
No, that's the complex time complexity. I think that max it has to have 10 to the power 9 cycles.
10 to the power 9 is just for not having an overflow in integer value. So
okay, yeah, because most of the places I see take mod value of
that is for integer
whenever result
overflow.
is.
Yeah.
Okay.
Okay, yeah, that's good.
Yeah. Any doubts on it? Okay.
No. Yeah.
Yeah. I just sorted it and then just checking if the next value is less than equal to previous value. Just take a difference and add a one and then update the next value and just moves. I've taken an extra variable move and add moves to it and last return the moves.
So the only thing that actually here is the sort. How what's the time complexity for the sort?
In
What is the
login,
implementation? In
this
login?
merge sort I'll use.
Merge sort.
I
Okay.
mean, it uses merge sort only inbuilt, I think, this sort function of Python.
Mm-hmm.
So
Okay.
this one n log n and order of n this one, so it will dominate. So overall, it will be n log n.
Okay. So no extra space, I guess. Yeah.
If, if it uses merge sort, that will use space.
Oh, okay.
No,
Yeah.
apart from that, I don't think so here. I think it should be n log n also.
Merge sort can be implemented within place also. If it's a library function, they might be doing it that way.
But I mean, after partitioning, we take in place. We can do merge sort.
It's very difficult to do, but usually the library function, they should do it. That is what I'm thinking.
Yeah, they have taken order of n. Oh, they have used count sort. I think here seems like, you know.
So it is the way Dilip demonstrated one, right? And that is the approach.
Yeah. Hmm.
So the sorting, I think, is the second approach.
Yeah.
Or not. Yeah.
I think this one, what Dilip says about, let's imagine an array is sorted. No. I think this one sorting approach.
Oh yeah, here actually the way you have done it's slightly different because he uses something like that. This give in the answer. There is a variable he takes give and then give multiplied by give plus 1 divided by 2. Then if it's an arithmetic series or something like that, and then he keeps on adding the
This
number.
one.
Yeah, that's a bit complex to understand, but that's also a good way of doing it. Space complexity he says n, so he's not counting that extra space of n log n there. Yeah.
Mm.
The way he talks about here in the two cases, the second one he says a minus 1 plus 1, a minus 1 plus 2 and all that till the end. Then he says the sum is a minus 1 multiplied by give plus summation of k is equal to 1 to give.
This is for summing all the natural numbers 1, 2, 3. This one.
That's
Summation
correct.
k equal.
Yeah.
And this one is for for multiplying.
Starting with one of those which actually starts assigning the extra numbers, whatever is earlier taken to be more than one. Yeah.
Mm. Mm.
But your is slightly different. You actually modify the array.
Yeah, I just check like if the next element is less than this one.
Mm-hmm.
So I took a difference, whatever, and added one to it, and then updated this one to whatever number plus difference.
Mm-hmm. And they keep on shifting it.
Yeah, we'll keep on shifting it throughout that.
Mm. Yeah, this is also good actually.
Yeah. So my approach and your approach were like trade-off between space and time, right? Like
Yeah, I think
Your approach is cleaner.
No, I think it's taking a login. And in yours, so it was.
Mine will take 10 to the power 4 max. It takes
So that's
constant power 4.
Yeah, irrespective of the input, his size is going to be always the same.
So if we need to decide which approach is better, like that, like even interview or like anywhere, which one is better to go for?
So I think time-wise, the way you did the lift might be better, right?
yeah, yeah, because constant apart from input is yeah.
Yeah. But if you look at this
Sorting approach is really very slow. Even in Java, I tried. So I believe counting approach will be better for this one.
But coming up with a counting approach in interview is also not so
trivial.
Yeah, it's not so easy.
that's
Yeah,
true.
it is. It will take some time. But yeah, if we keep on doing all these things more number of times, we might be able to do that too.
Yeah, it needs to be.
But if we are following our intuition, it will be first sorting, right, and then kind of move like in this example that Shashank provided.
Your first attack comes like we need to go with the sorting because that's a general approach, like common.
Yeah.
And then you provide the moves for each and every. Okay.
Yeah.
Yep.
Okay. Okay. So
That's good.
okay. I'm stopping the recording here.
Sure.
Thank you, guys.
Oh.
Thank you.